On this first problem, when we add or subtract fractions, we do need common denominators. So in this problem, the common denominator would be 15. We can rewrite the first term as 10/15, and we can write the second term as 12/15, for a final answer of 22/15. Part B, if you're multiplying fractions, we do not need common denominators. So we can just multiply straight across. 5 times 2 is 10. 6 times 7 is 42. And then we can reduce this because both the numerator and denominator can be divided by 2. And there's our final answer. And some people will do the reducing in the beginning when they multiply fractions. In other words, 2 factor on top divides into itself once, and it divides into 6 3 times. And then when they multiply, 5 times 1 is 5, and 3 times 7 is 21. When we divide fractions, we can rewrite it. The dividend, first term, remains the same, and multiply it times the reciprocal of the second term. At that stage, you have the option of reducing right now, or just multiplying numerator times numerator, 15 times 2, denominator times denominator, and then reducing. A 6 divides into 35 times, and 6 divides into 12 twice. If you had done it earlier, 2 goes into itself once, 2 divides into 4 twice, 3 divides into itself once, and into 15 5 times, and now when you multiply, 5 over 2. Since all measurements are in meters, our answers representing area will be in square meters. For a small rectangle, base times height, 2/3 times 4/3. The area is 8/9 square meters. For the large rectangle, base times height is 4 times 4/5. Number 4 can be thought of as the fraction 4 divided by 1. And so that when we multiply, the answer is numerator times numerator, denominator times denominator, 16/5, or 3 1/5 square meters. I don't really care whether you leave your answer in this form, or this form, or even this form. They all represent the correct answer. Now for part C, these problems are generally a subtraction problem. If you want the blue region, imagine that you had the entire large rectangle, and then you cut off the yellow inside. What will be remaining is the blue region. So the area of the blue region is the entire blue rectangle, which is 16/5. Subtract the yellow inside rectangle, which is 8/9. Excuse me. And if we are doing this without a calculator, we will need common denominators. Adding and subtracting fractions requires common denominators. All right, so the common denominator might be 45. You look at the red, the green, see that I'm multiplying times 1, which does not change the value of 8/9. I'm multiplying times 9 divided by 9, which is 1. And multiplying by 1 does not change the value of 16/5. So our new fraction here then, our new subtraction problem is 144 45ths. Subtract 40 45ths, which is 104 45ths square meters. or if you prefer, that would be 2 and 14/45 square meters. And if you had no calculator and you wanted to estimate this, 15/45 would be exactly a third. So this is just 1/45, a very small fraction shy of 2 1/3 square meters. But either of these answers are acceptable. We know that the area of the triangle is 1/2 times base times height. So the area of this triangle is 1/2 times 2/5 of an inch times 5/8 of an inch. Multiplying all the numerators, 1 times 2 times 5 gives us a numerator of 10, and 2 times 5 times 8 gives us a numerator of 80. So our final answer is 1/8 square inch. 1/8 was square inch. In this problem, if we want the blue region, it's again like one of those problems where you can imagine that the entire triangle is a board, and you only want the blue region, so you're going to cut out the circle. And once you cut out the red circle and throw it away, all that's left is the blue region. So in this problem, this is the same triangle as in the last problem, where the area was 1/8 of a square inch. And when we subtract the area of the circle, and we will give you the formula for the area of the circle. Most of you already have it memorized though. Pi r squared, and the radius is 11/64. The entire triangle minus the part in the middle will give us the blue region. For this, I would use a calculator. So let's go ahead and do that. One-8 minus pi times the radius squared. So we have approximately 3/100 of a square inch, 0.03219. And that squiggly equal sign is how we imply approximately equal to. Now that you have the general idea for finding the area of these regions for which we don't have formulas, this blue region is not a shape that we have a formula for, you understand that the process is to find the area of the entire board and then cut out the green circle in the middle, and what will be remaining is the blue region. In this problem, the area of the rectangle is base times height, and the area of the circle is pi times radius squared, and you needed to deduce what the radius was. So in this picture, the radius has to be 10, since 2 radii is 20. So we have 1,200 square centimeters, subtract 100 pi square centimeters, which is approximately 885.84. Square centimeters. That's 10 minutes, and we are through problem 4. Next video, we'll take off with number 5.